All right, so our first speaker for this session is Dr. Patrick J. Burns. He's a research associate professor at the Institute for the Study of the Ancient World. Dr. Burns is the maintainer of LatinSci, pre-trained natural language processing pipelines for Latin, a co-author and developer for Latin BERT, and has been a contributor to the Classical Language Toolkit. His paper today is titled, Is Agentic Philology an Oxymoron? Some Thoughts on Error, Control, and Disciplinary Definition. Let's give him a hand.
So thank you very much for that generous introduction. I want to thank Corey, Serena, Francesca, the Rutgers students, the Rutgers department for having me. This is really an amazing event, and so I'm very happy to be part of it. So today I'll be talking about agentic philology and some projects I'm working on right now. I've had a lot of coffee. I have a lot of slides. I think those are going to come together nicely. So what does it mean to do philology is my starting point. And so in an article earlier this year, Johannes Albold, Miriam Kotwick have an article on Aristotle. And I want to point out that this from the abstract. We conclude that language models like Logion, which we heard about earlier, really wonderful to be in the company with the project, can contribute to the current revival in the study of Aristotle's texts, provided we use them responsibly and hold on to the fact that while machines may make intriguing suggestions, only human philologists can ultimately adjudicate philological problems. I want to drill down on this only human philologists and really the only. We'll keep that in mind. So this grows out of earlier Logion publications. We have the Tappa article. And this is where we get this idea of doing philology, which also derives from Sheldon Pollock's future philology. And I like this quote from Pollock here. We learn more about why this discipline is important and how to do it better the more we pluralize it by learning how others have done it differently. So this inspires me to think, what would different philology look like? That's background one. Background two, agents have come up throughout. It's hard to avoid them in the discussions of artificial intelligence these days, but I want to make sure we're talking from the common definitions. So let's think about what is agentic AI, right? This is from Russell and Norvig's textbook on artificial intelligence. And so we want to think an agent is just something that acts. I mean, that's some good Latin etymology, right? And then we want to think about a rational agent is one that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. I think all of us dealing with any ancient world data condition can say that uncertainty is the establishing fact. So we want to see what the best expected outcome is where we can when we're doing computational philology. Okay. Agentic AI really had its moment like last November, really burst on the scene. Claude Code sort of changed it. So is it magic? I mean, it's just like code being written by computers for itself to write more code. Is it magic? Is it fluff? Promise? We don't know. We're figuring it all out. The future is agentic, says that t-shirt. We have agentic AI in the form of Claude Code. We also have Claude Code deploying sub-agentic AI, and then with the open claw stuff, I mean, like we have autonomous agentic AI where their code is being written for itself to speak to itself. It's really this is a brave new world sort of condition here for philology. And if you haven't, how many people have used an agentic code model to write, right? Okay, so it's like, it's getting there, but like, I mean, it would have been zero like 2 years ago. It's just like, you just watch your computer screen, like write code and you approve it. And I mean, there are moments of magic. So I just want to take you back to what I was thinking in January. I was talking about this is the SES, a brief summary of the errorful state of massive Latin collections online and why I'm thinking about novel definitions of philology and agentic philology at the same time. So at the SCS this year, I declared a philological exigency. I don't go to the SCS and have the emoticon or the emoji for the sign there. And that is basically the amount of Latin that's available on the internet right now that we can work with productively is way beyond human scale. We're not dealing with a lot of Latin. We're dealing with magnitudes and magnitudes of a lot. Okay, that's only the philological exigency. I also declared I got the siren emoji up too, a philological emergency, where part of the thing is there's more corrupt Latin text on the internet, and again, billions of words, as we'll see, than there is quality Latin text. And as I declared, the emergency was that this will only worsen if we don't do something about it. Okay, that's what the emergency is. So my takeaway for that was that computational problems require computational solutions. And so we need to enjoin people in CS to address those errors, and that we probably need to seriously think about training either philologically informed correction models. I think that's reasonable. And this is where maybe it's not reasonable, and you can push back on me if you want here. Develop agentic solutions to meet this computational moment. Can we let the computers do some of that philological work for us? Okay, so back to that responsibility word that was in the first abstract from Kotwick and Albald. I take it seriously. I'm deeply sympathetic to that idea that only human philologists can ultimately adjudicate philological problems. I'm trained in this field. I have respect for the field. I feel also pressured by the entropic realities of this massive amount of Latin text online and this idea that computational problems must require computational solutions. So I am compelled by the idea, again, taking it from Pollack through Graziosi et al., that we learn more about why this discipline is important and how to do it better the more we pluralize it by learning how others have done it differently and thinking differently myself. So, okay. Haven't we been there before? I mean, it's not the first time we've had a lot of Latin or Greek or whatever we want to talk about. Greg Crane and his team were talking about this a decade ago, cataloging for 1 billion words of Latin and Greek. I would say that's true, but it really hasn't been until very recently that we've been able to really use those 1 billion words. I'm currently on my laptop, have billions of words of Latin, and I'm training models on them right now. The era of the 1 billion word collection for Latin is here. And we are still preparing for more. The computer's blocking. They don't want you to see the trillions. But I had somebody say the other day to me, legitimately, like, why don't we just make synthetic, why don't we just have 1 trillion words of Greek? I was like, all right, whatever. But these are the kind of questions that are coming up. So we have to be prepared. Okay. So let's establish some more baseline information. How much Latin is on the internet? Maybe you've seen me give this before. I apologize, but if you haven't, then welcome to a lot. A question for the room. How many words of Latin, or you can fill in whatever, have you read in your life? Has anyone ever thought about this? It's a lot. I mean, you can take some pride in having read a lot of Latin and Greek, but it's not this much. Okay, so you could sit down and read Catullus in an afternoon. That's fine. But could you read all of Perseus in an afternoon? No. I mean, it would take lifetimes to read everything that's on this slide. And this doesn't even get to this is barely 100 million words here, right? All right. So how am I finding billions of words of Latin? Might be a good question, right? If all of Perseus is only 6.5 million words, it's a good question. So large language models are training on quote unquote all of the internet. And of course, if you have all of the internet, that means you also then by definition have some of the internet. Some of the internet is Latin. It's not that much, but it's actually a pretty substantial amount. And so I've adopted as my Latin motto word for this, everriculum. This is not a word that I was particularly familiar with before. I could have figured it out. But this is the trawl. This is the net that sweeps up everything, right? Latin is one of those fishes in the trawl of data on the internet that is pulling in the language models are mostly trained on other languages, and still that one fish winds up being a couple of billion words. So with that Latin in LLM training data repositories, especially in the open source development side, I can go and download those. They're easily available and packaged. So I can go to Playos's Common Corpus, the largest multilingual open pre-training data set. All right, they advertise 34 billion words of Latin in their collection. I can tell you it's an overstatement. But where is it coming from? We have collections like the Latin that's been scanned from the book scanning projects of the last days. I can get the ones that are in the Internet Archive, the OCR scans of all of those books. That's available. Institutional books, an initiative by Harvard Library and the Law School. This is in fact the highest quality amount of a lot of Latin. I can get like 4 billion tokens, so like 1 billion words of high quality scanned Latin. Just download it today, right? This is the first one I showed you. They say there's 36 billion tokens. So there's just a lot out there. What's there? This is the problem. This is the exigency and the emergency I was talking about before. We want Latin. What we're getting at the best is probably Latin-ish. That's OCR corrupted Latin, where you can see like E5T is one of the most common words in the Latinish language, right? It's just est, but the OCR got the S wrong as a 5. There's tons of long eft. Also, have you ever seen long S in the wild? Latin-like is really a problem. That's when you have things that look like Latin, like lorem ipsum, but in fact, it's not there. That's useless. We got to get rid of that. And then there's just total noise. But the amount of Latinish that's available is probably going to help us in our field. And I think we want to get the Latinish as good as possible, maybe even close to Latin. These are weird sentences for me to say out loud. So when we think about massive Latin, Perseus is a lot, 6.5 million words. If you take like something like Corpus Corporum, we have 225 million words. Like Latin BERT, as we heard discussed earlier, that's a model that's doing good competitive work in the world. It was only trained on 560 million words of Internet Archive Latin. I'm dealing with a lot more now, and I'm dealing with it productively. Okay, gotta be careful. What does a billion mean to any of you? I mean, just out of curiosity, like it's a lot, right? So let's use a temporal metaphor really fast. Does anyone know how long in time 1 million seconds is? And they didn't see when I advanced in the slide a second ago? Anyone happen to know? Okay. It's 11 and a half days. Do you remember what you were doing 11 and a half days ago? Can you predict what you're going to be doing 11 days from now? Probably. Anyone know what 1 billion seconds is like?
Fall of the Roman Empire.
It's 31 years. Okay, that's how much more 1 billion is than 1 million. Okay, so when I'm talking about a lot of Latin, a lot doesn't really mean something. I'm talking about way more Latin than you've ever been around. Okay, so when I say something like 6 billion tokens, we need to take that seriously. It's just it's a scale issue. Humans are not going to fix the errors that are in that collection. Okay, why even bother? That's a good question. But we have things like Latin BERT, which is trained on a fair amount of large collection, noisy Latin data. And it's doing, it does excellent part of speech tagging. It does excellent text infilling, all the kind of things you saw. Logion is also trained on a lot of data. When you have a lot of data and you're using it and marshaling it correctly, it can do really interesting philological work at scale that we didn't have available to us in the past, right? Even smaller things like the Latin C models are doing interesting things too. And they'll only get better if we have better models to support it. So I've been working mostly on Latin BERT version 2 for quite a while, and the only way I can get a better performing Latin BERT is to have more data. And so that's why I'm spending so much time on working through these massive collections, trying to filter them where possible, trying to remediate them where possible. So what are the challenges of working with massive data? Well, here's a unicorn. This is my pet, my mascot for the project. I love this Gessner story on the unicorn. Let's look at, this is what the text looks like in the Google Books scan. And you'll see there's all sorts of things that make it hard to read. And all of those wind up also existing as artifacts, de verify funt. That's some good Latin there. These all persist at scale in the Latinish record. Okay, you can see some things that are scanned come out really nice and vaguely readable. Other things do not. We can correct these. Honestly, the commercial models are very good at this. All right, just be honest, but the cost on doing the remediation on 40 billion words of that would be a lot. And I think $13,000 is an under. I mean, that would assume I made no mistakes and it was a single pass success. Anyway, it would be too expensive to just assign this to a frontier model. And even when you do get like hyper corrections like auditis for auritis. Yeah. But I can't help but note that this is philology, though, right? I have a bunch of corrupt files or corrupt texts, and I'm fixing them. That's text criticism. Okay, so we're good. And I can turn to text criticism as a model for this kind of work. Zetzel talking about like the role of the philologist is reconstructing what was rather than enshrining or embalming the errors. That's the emergency I was talking about before. I don't want to embalm the errors, right? So we want to leverage computational scale and speed to mitigate those errors, right? I do feel a responsibility to that. So I'm caught between philological responsibilities, right? Looking back to the paper I showed you earlier, right? Graziosi et al. Like we have tried to show that machine learning opens up new and exciting possibilities for the future of philology in terms of method, infrastructure, pedagogy, and practical applications. We have, however, also insisted that many of the ethical challenges raised here are, on close expression, not new at all. Insights derived from past philological practice can help meet them. I do feel that they're right to place some of the, only humans can adjudicate. I'm really sensitive to this idea. And yet, I'm gonna move ahead a little bit, so I'm not out of time. I do wonder if we have problems just with doing that when the collections are so big. I'm reminded of the stochastic parrots paper, which you may be familiar with, let's go ahead. That Bender et al. Here start talking about, when we have data sets that are so big and they're so probabilistic, they don't have any reference to meaning. That doesn't mean that they're not meaningful to us in specific capacities, right? Underwood's response here talks that when we're dealing with these ideas from the past, we don't have direct access to minds, right? We don't have living subjects. We mostly work with texts and other traces. We're already always in a case of modeling. Why can't we do something to improve our models? I feel like a responsibility to that. So I want you to all ask, right? If we're already using stitched together linguistic forms for the basis for our research outputs, like how do we describe and characterize these data sets? I think we need to. And where does this question fit into that call for help that Underwood asks us to do? Well, that's where I'm headed. That's where I'm stuck. I feel again I'm caught between these responsibilities, right? So I turn it back to you as well, and these are the questions I wake up to every day. What is our philological and curatorial responsibility for those LLM repository texts? I know they're errorful. I know people are duplicating. Every time someone downloads them, there's twice as many errors in the world, right? This is an entropic problem, right? What's our responsibility once I correct those texts, right? I need to make sure that they're at some quality so that I'm not becoming a part of an error propagation system either. What if we do make synthetic text based on these? That I feel a responsibility for that as well. So since they're not human scale, I started asking myself, am I comfortable? Are we comfortable with processes like fully automated description, fully automated agentic correction? Can I just set computer models out in the world to do that correction and figure it out itself? Can we take away that only from the first slide? Stated otherwise, how much control do we want, expect, demand, need in philology? And then I couldn't resist another Latin etymological thing here. What would we need to have in place to trust automated or agentic processes? Is it even curation? So we want to make sure that this is from Brian Christensen's alignment problem. And this is why the question of being caught between responsibilities means something to me. I don't want to abdicate the norms and values I've already adopted in the field, and I don't think I need to. I really am trying to solve an exigent and emergency problem. So I do want to just then leave with saying I drilled down originally on the only human philologist and then circled only. But now I'm wondering if it's really like the human that we really need to reconsider here because of the scale issue. And so I think to myself, who is my Latin audience now? Who is our Latin audience? If I'm curating Latin content in order to train the next version of Latin BERT, my audience is that model. My reader is the computer. Accordingly, I can convince myself in this case, or so in any case, that there is responsible philological application that does not require human adjudication, at least not directly. And so perhaps opening the door to agentic approaches to philology, I'm seeking the best outcome, or at least the best expected outcome. You can tell from the way I delivered that gasp at the end, I'm deeply uncomfortable with some of the implications of my own paper. So I turn the question back to you. Is agentic philology an oxymoron? I think these are questions we need to ask right now in this moment. So thank you for entertaining the idea.
Thank you so much. That was so interesting. All right. Okay, our next speaker online is Dr. Ethan Gruber. Dr. Gruber is the Director of Data Science at the American Numismatic Society, with more than 15 years of experience in digital humanities and cultural heritage web development projects. He is responsible for developing all the Society's digital collections, library, archives, and research information systems, such as online coins of the Roman Empire. His paper today is titled AI and Numismatics, Latest Advances in Classification and Accessibility.
Hello, my name is Ethan Gruber. I'm the Director of Data Science at the American Numismatic Society. And today I'll be talking about AI tools and numismatics, the latest advances in classification and accessibility of coins. I will be focusing most of my presentation on recent advances in natural language processing within American Numismatic Society projects, but I will also touch on some other recent advancements in using computer vision and machine learning techniques to aid in classification of coins, as well as die studies of ancient coinage. So first, I'll start with a practical example from the American Numismatic Society database. So one of the issues that we have in searching is that the search indices that we use for our collections database, as well as our online type corpora, such as online coins of the Roman Empire and coinages of the Roman Republic online, is that the search, keyword search, is very literal in terms that it only searches the words that are encoded into the database for the obverse and reverse descriptions. So that means that there's no semantic search that really tells you that one term is basically the same or equivalent as another term within the database. So in order to illustrate this, I've picked mountain lions on coins and medals within the ANS collection. So having grown up in the mid-Atlantic, I often said mountain lion, or always said mountain lion to describe these animals. Although there are quite a lot of people around in the East Coast who call them cougars as well. Fundamentally, a mountain lion and a cougar are the same animal. They're just two different names for the same animal. But if you want to search for these animals in our collection, you really have to know every possible permutation of mountain lion in order to get all of the results that you're looking for. So, for example, there are numerous occurrences of the word puma. Puma is often used within the Southwest and South America. It is, in fact, a genus of big cat. It is a genus with only one extant species, and that is the cougar. However, puma and cougar are used interchangeably. The other term other than cougar, puma, and mountain lion is catamount, which is almost never used in common conversation, yet there are still some examples of the use of this word within our own database. So if we search for puma, we'll get 5 results within the database. If we search for cougar, however, which is far more commonly used within the United States for this animal, you'll only get 1. And then if you search for catamount, you will get 2 results for American coins within our database. These are really a result of the idiosyncrasies of the cataloging within our database, where different curators may have had different opinions about what to call these animals over time, even though catamount is certainly the least commonly used word for mountain lion. Now, if we search for mountain lion in our database, you will get 3 results, because there are 3 medals in the collection that depict an African lion in the foreground with a mountain in the background. That's obviously not what we're looking for. So if we put mountain lion in double quotes, as you would expect to do in a Google result search to find just the phrase mountain lion, there will be 0 results. So even though mountain lion is quite commonly used within the United States, nobody who ever cataloged objects in our collection seemed to have used it. One of the fundamental pieces to making our collection more searchable and accessible is wikidata.org. Wikidata is the linked open data backend to Wikipedia. So anything that would have an article in Wikipedia has a Wikidata URI and underlying linked data to represent it. So in this case, there is a URI for cougar because there is a Wikipedia article for cougar. And Wikidata is especially useful because it includes alternative labels in various languages, as well as preferred labels in other languages such as Spanish or Chinese, which enables technical developers to build multilingual user interfaces on Wikidata. So this is a really useful tool for us in order to be able to associate mountain lion, puma, catamount, and cougar, because these are all different languages, labels in different languages stored in Wikidata. So to turn our attention to a use case that's more specific to the ancient world, I will use snake and serpent as an illustration within online coins of the Roman Empire, which is one of our largest and most heavily used online type corpora. So if you search for serpent within ochre, you will get 273 results. But if you search for snake, there will be 589 results. These results do not overlap at all because of the inconsistencies in the description of Roman imperial coins over a 10-volume corpus. And it's not only that the use of serpent or snake is inconsistent across volumes, it can also be inconsistent within the same section as the same volume. So on the left, you'll see there are some results for the Roman Emperor Galba and a serpent appearing on the reverse of a coin, but you'll also find the word snake was also used in other coin types of Galba. So it's a very complicated, you have to know every alternative label for an animal if you want to find all of the results within ochre. So the fundamental technology that allows us to improve accessibility is natural language processing with the natural language processing toolkit in Python. So using Asclepius nude standing front, head left, leaning on small staff with serpent coils as an example, I will show you how to go from this reverse description of a coin type to equating snake and serpent as equivalent concepts. So the summary of the technical workflow is that we first want to parse all of the descriptions within online coins of the Roman Empire. And there were really many tens of thousands of unique descriptions within the corpus. We then want to reconcile the concepts that we extract from the natural language processing toolkit to Wikidata, which then enables us to extract alternative labels as well as hierarchical labels. So that allows us to say that a snake and a serpent are different labels for the same concept, but also that a snake is classified as a reptile, which is also a type of animal. And that opens the door to being able to search for reptiles on coins and finding all of the snakes or lizards or what have you. And then the next step after that is really to incorporate these reconciled results into the user interfaces for Ochre and other projects to facilitate improved searchability. So the first step of this process is tokenization. So this is essentially breaking down a sentence into its constituent words. So we run that previous description through the tokenized process, which simply breaks the sentence down into an array of words. We then tag these words with their parts of speech. So this essentially assigns Asclepius, staff, serpent, etc. as nouns, which are the types of words we are primarily interested in this process, because nouns are essentially concepts in this case that can be reconciled against Wikidata. We then extract, after extracting several thousand words, we then whittle down the ones we don't think are particularly useful. And in this process, we reduced, I think, more than 4,000 terms from the tokenization process down into 1,600 distinct and useful terms, which we then reconcile to wikidata.org. And we reconcile these terms to Wikidata through OpenRefine, which is an open source platform designed for the large-scale cleanup of data. And one of the really useful things that OpenRefine does is allows us to interact with APIs provided by Wikidata to find the associated URI within Wikidata. Once we then reconcile all of these terminologies to Wikidata URIs, we can then begin the process of extracting relevant labels, both for the term and its hierarchical classifications. So this is a page depicting the concept of aegis in Wikidata. So you'll see there are different spellings and different labels of this concept, and it is also hierarchically classified as a type of shield. And if we drill down into the Wikidata concept for shield, we'll then see that there are different labels for shield, and it is also classified as both body armor and a defensive weapon. So that's really useful, I think, for people who are interested in the depictions of armor on coins. So somebody could do a keyword search for armor, and it will display all of the shields and breastplates and helmets and that sort of thing, because they are all classified as armor within Wikidata. And in order to extract these, we use the Wikidata Sparkle endpoint for each of these terminologies in order to get all of the alternative labels and the hierarchical labels as well. The HTML representation looks something like this once we execute the query, but within Python we actually use the machine readable data underlying the query and then populate that into an API. So once we pre-populate these reconciled results into another API based on FAST API, JSON library or a Python library, this allows us to then pass the obverse or reverse description of the coin into the API to get back the Wikidata URIs for each of these concepts. So these are all pre-populated from the previous step rather than done on the fly, because it's really important to keep this indexing process as fast and as efficient as possible. Similarly, there's a secondary API that contains the alternative labels and the hierarchical labels, which we then use for the indexing part. Once we have these APIs and incorporate them into the data publication workflow, we are then able to put them into the record for Ochre, and then use them in the indexing process. So after re-indexing the entire collection, after inserting those hierarchical or those concepts and their associated Wikidata URIs, we can then search for snake within Ochre and get almost 750 results back. So it includes all of the results that include the word snake literally, as well as those that include serpent, because we have previously equated serpent and snake as the same concept. We can extrapolate this a bit further by searching for architecture in Ochre, and we'll get more than 4,500 results, which includes temples, altars, columns, gates, and other sorts of features, which are all classified by Wikidata as architecture. Similarly, if we search for animals and Hellenistic royal coinages, we'll get more than 6,000 results for anything that might contain eagles, horses, crows, virtually any sort of animal that occurs on the coin. As I touched on earlier, one of the reasons we're doing pre-processing is that the databases really have to remain usable. So the indexing is done beforehand rather than using LLMs or generative AI in real time, which would really reduce the usability of the process. The Wikidata process also includes human vetting, which is really important for quality control, especially since researchers are constantly using these projects for their own scholarship. So it's really important to us to be able to deliver accurate results to people who are using these resources. The limitations, obviously, are that it really depends on the textual descriptions that are provided. So there's no computer vision aspect to this. It really depends on the quality of the textual description. So you only really get out of it what you put into it at this point. One of the big limitations will be once we apply this to our own collections database, the descriptions are not as consistent or complete in our own database as they are in the highly curated Ochre or other typology projects. After we've implemented this in Ochre and the typology projects, the next step is to implement it in Mantis as well. Fortunately, since some of our coins link to these coin type corpora, we're able to extract the data from the type corpora such as Ochre into our own indexing process for our database. So after republishing the natural language processing for Roman Republican coinage, we can then search for architecture and Roman Republican coinage, because some 200 coins link to 29 types that feature some form of architecture. So there is some trickle-down effect eventually for those Roman and Greek coins which link to type corpora for incorporating improved searchability from NLP before we move on into working on other departments which are not ancient coinage. So I'm going to briefly switch gears to talking about computer vision applications now. Scholars have been using coinage for nearly 20 years as a basis for testing computer vision methodologies to identify coins. The process was really slow going until about 2015, when really high quality off-the-shelf applications for image classification became readily available to work on. One of the other advances is that these type corpora that we publish have many hundreds of photographic examples, even by typology. And that has allowed experts to use these high-quality images and high-quality data as test data for image classification. And so one of these example projects is Ancient Coin ID, which is allows you to upload your own photos of Roman imperial or Republican coinage, and it will identify the type with a really high degree of accuracy because of the volume of training data that is available on the web for these types of coinage. So most of the Roman Republican coins, since they have so many photographic examples, can be identified with 98 to 99% accuracy. Digging a little bit deeper into computer vision, beyond just simple classification of typologies, are dye studies. Dye studies are essentially, there were multiple obverse and reverse dyes per series of coin, and this computer vision technique allows you to analyze the photographs of physical specimens and then link them to obverse and reverse dyes. This is a really useful scholarly methodology for economic historians who are interested in speculating how many coins were produced in a series, in particular, and how they circulated throughout the ancient world. And so some work began in about 2013 to 2014 on a project which had been funded by the American Numismatic Society called CADS, Computer Aided Dye Study. And that proceeded using Athenian drams and tetradrams as a test case, and was also applied to some other fields of numismatics. There's a lot of other progress being made by other institutions and other partnerships outside the ANS in both Roman imperial coinage and in Iron Age coinage from continental Europe. So these computer vision techniques allow you to feed hundreds, thousands, or even tens of thousands of images into a system, a machine learning system that allows the clustering of similar dyes for the obverse and reverse of coins. And then a human can then vet these clusters to make sure that they're accurate. But the results are extremely promising. The accuracy is growing all the time. And so the Iron Age project is particularly interesting because a lot of these designs are more abstract than Roman or Greek coinage. And the dies for Iron Age coinage are often larger than the flans, which mean that the designs may not be perfectly centered, and pieces of the design are missing from one coin which may be visible in another, which is kind of a unique problem to Iron Age coinage that you don't find in Roman or Greek coinage so much. So the progress in using computer vision to analyze these dies and find them even though they're sort of off-center with pieces of the iconography missing has allowed a great degree of clustering, and it really accelerates the speed at which a scholar can conduct a dye study from the period of years down to weeks, really. So in conclusion, we're using a multitude of AI tools, including computer vision, machine learning, and natural language processing, but we haven't really delved too deeply into the LLMs due to issues with accuracy and efficiency in making real-time databases that people can use on the web. Thank you for your attention.
Our keynote speaker for the conference today, Dr. Akash Kapur, is a visiting research scholar and lecturer at Princeton University. His work focuses on digital public infrastructure. He examines the global dissemination of technology and governance frameworks for digital identity, payments, and data exchange. He is the author of two critically acclaimed books, Better to Have Gone and India Becoming. Both were named Editor's Choice by the New York Times. He has worked or consulted on tech policy at various places, including the Markle Foundation. He is also a former columnist for the New York Times and has written for various publications, including the New Yorker, the Wall Street Journal, and the Atlantic. The title of his paper today is Looking Forward.
So the title's changed a little bit. When we decided to start, I wasn't sure if it was going to be optimistic or pessimistic because I kind of work in both registers, but we decided it's going to be optimistic. And thank you all for having me here. And, I wanted to start with a confession, which is that when Corey asked me to be here, I had some trepidation. And part of the reason is because the field that I work in, I tend to interact primarily with other technologists, economists, policy people. And so there's sort of kind of like a safe little bubble where we have a certain vocabulary, and I can tell that the vocab here is a little different, and we're gonna work on bridging that. But for example, you'll see I probably talk a lot more about infrastructure than I do about like the content and the apps. But part of the point I'm going to be making here, both implicitly and explicitly, is that those two are actually quite linked. So I'm going to get into some of that. But also one of the reasons I wanted to do this is, I feel like I'm trying to curry favor with the room, but I am also a humanist, actually. I studied anthropology in college. I've taught humanities courses at Princeton, and also I'm a writer, right? And so, in that sense, I come from that. I've written nonfiction literary books. I write for the New Yorker, and I think I kind of come from that corner of the world in a way that is feeling kind of embattled and not very pleased by AI. And part of the reason I wanted to be here is because I've been thinking a lot about that sort of like difference between my two worlds and the kind of like mutual suspicion and skepticism and even hostility between the kind of like tech policy world I work in on the one hand and the kind of humanities writer artist world that I inhabit on the other. And so that's one of the reasons why I wanted to be here. Just, I suspect that the mood in this room is actually, from what I'm hearing, is less hostile than I hear, especially from a lot of my journalism friends, for example. But nonetheless, that is a real thing. And to be honest, I share a lot of that, right? Like the thing I'm talking about today is, what if AI works out? I am working on a paper at Princeton called "What Would the Enshittification of AI Look Like?" So I kind of get both sides of this equation. I guess if you guys, I don't know how many of you are familiar with the enshittification meme that's going around now, right? It's Cory Doctorow's phrase for what sort of happened to AI, what's happened to technology over the last 20 years or so, that we were sort of sold a bill of goods, and we ended up with this very toxic sort of environment of platform monopolies and sort of like data extraction and so on. I think I share that skepticism, I share that hostility to an extent, or at least fear. But part of what I want to sort of suggest today is that with AI, we are kind of still early in the trajectory of this technology, and we still have choices and we still have decisions to be made. And what happened with the digital world in general is, I think there was a certain amount of naivete. Some of it was willed naivete, but we didn't really see what was coming, right? And by the time we woke up, it was a little bit too late. And certain things had been baked in, both at the technology level, but also at the policy level. And just at the kind of normative narrative level, we all sort of bought this, like, well, leave it alone. Technology can't be touched. It's unregulable, that kind of thing. We're early enough with AI that we've seen that movie. We know that that's a possibility, and I think we have choices to make. And so part of what I want to do here is talk about three areas that I'm working in particular, that to me call them glimmers of hope or hopeful trajectories for where AI could go, without making the claim that we're there yet. But I think that we could take a much more hopeful path if we press the right levers and sort of go down the paths of these sort of three incipient developments. So that's going to be the structure of the talk. Again, none of those pathways are inevitable, but they are possible. And before I get into those kind of three pathways or those three factors, I wanted to talk a little bit about what I think has gone wrong in tech over the last 10 or 20 years, because I think that sort of sets the stage for what could go right. So, you know, of course, like many things have gone wrong. But I want to focus on this one aspect that I think is responsible for a lot of the downstream harms, and that's basically the lack of diversity, the lack of multiplicity in the tech ecosystem, right? In a more kind of wonky economisty way of saying this is just the lack of competition, there's just been this really striking and, in my opinion, very corrosive lack of competition in a field that was actually supposed to be defined, and to some extent we still think of as being defined by disintermediation and a level playing field, but that hasn't been the case at all, right? So, I mean, I was thinking about this. Like, imagine you are a parent. I was a parent in 2019, say 2018, 2019. Your kid is spending an inordinate amount of time on Facebook or Instagram or whatever. At this point, you probably know this is bad for them. You're not naive anymore. You've seen this firsthand with your kid. You've read about it in the media. You've probably read some academic studies about this. And so the question is, like, what do you do? Right? You could try banning your kid from social media. That certainly wouldn't have worked in my household. I know some parents who are a little bit more successful. I had lost that battle a long time ago. So what do you do? So, if this was an airline or if this was toothpaste, what would you do? You'd switch brands, right? You'd stop using the poisonous toothpaste and you would go buy like the healthy toothpaste or take the safe airline, right? But of course, like the key, almost the defining fact about the tech landscape in recent years is that we haven't had any choice on many of these platforms. There were no competing brands, or there may have been one other competing brand that was just as bad as the platform you were already on. And so, the centralization, like the figures up there, I guess I won't go through them, but that gives you some sense of the centralization in the field, right? It's really an extraordinary level of concentration. Like there may be other sectors out there right now, but I can't really think of other sectors where we have this level of concentration and this level of centralization and monopolization in the field, which is why we don't just talk about platform economies, we talk about platform monopolies, right? Okay, and so how did we end up here? Some of this was policy failures. I think it's pretty well recognized now that the decision in the 2010s to let Meta, at that time Facebook, buy Instagram and WhatsApp was a mistake. And that's why Meta now owns the 4 largest social media platforms in the world, right? And has basically unified them. Some of it also just stems from the nature of digital markets and those famous network effects that we all know about, which is why even those of us who really recognize, like, Facebook is not good for me, we're probably still on it, right? Because all our friends are on it. And, it's been a decade of talking about data portability and network portability, and you should be able to leave with your network from Facebook and move to another platform. It hasn't happened because network effects are very, very sticky in the language that I tend to use. But anyway, so whatever the cause, like, the point is, like, if users had real alternatives and if they could have moved to better platforms, I think a lot of the harms would have been mitigated without the need for heavy-handed regulation that may or may not have stifled innovation. Consumers would have just made choices for themselves. Consumers and citizens would have made choices for themselves that were healthier, that were better for them, that were better for their families, and probably that cumulatively would have been better for society. Okay, so that's the kind of at a high level understanding of what has gone wrong in this ecosystem. And just to say, like, returning to AI, the risk and the fear at some level, we all have many fears about AI, but the one that I think about is the repeat of this centralization, right? And in many ways, the structural pressures in AI seem to be even stronger than they were, in the early years, at least, of the platforms, partly because of the financial pressures that I'm sure you all know of. That the cost of training a frontier model from scratch is about $1 billion now, right? That does not seem conducive to, like, a lot of, like, startups coming in and creating competing models. Okay, there also, in addition to the to the financial constraints, there are huge talent and capacity constraints, right? I was reading an article in The Economist recently where they estimate that there's only about 100 people in the world who actually have the knowledge to build these models from scratch. And I called some techie friends of mine. I was like, can that be true? Like, I feel like I know tons of computer scientists that know this. And they were like, well, it's actually an art, right? It's like turning the dials, like knowing how much to use, what GPU at what point. And so that's a huge constraint, which again, like suggests, very much that we could be leading to one of these sort of concentrated situations. And on the surface of things, on the face of things, I'm going to make the claim that that's not exactly the case, but on the face of things, this is what seems to be happening. A handful of companies, 2 countries, USA and China, look like they're going to be dominating this field. So, okay, so maybe we're playing the same movie that we've seen before. Maybe the harms will be familiar. We might also have a whole new range of harms, or the harms might be much worse. I mean, I think, misinformation was a problem on social media. Misinformation could be a lot worse in an unregulated, uncontrolled, overly concentrated AI environment. And then there are all these fears. I mean, leaving aside the kind of like existential fears, which I don't dismiss, but I take with a grain of salt, the bioweapon fears, all these things. But the people, people in the labs are talking about things like hyper persuasion, right? The idea that these models are going to get so psychologically sophisticated that they're going to be able to start manipulating and convincing people to commit criminal acts or harmful acts to themselves and to society. That's a whole new category of risk that I don't think we understand very well. So, okay, that does not sound like the title of my talk, right? I think we need to move on from that preamble, which is me kind of like covering my bases. Like I get the potential problems and I get the risks. But that being said, okay, I work in AI, not just in the US. I think some of these problems, by the way, are particularly pronounced in the US, and I'm going to return to that. I work in AI in the global South. I work in Rwanda. I work in India. I work in a lot of parts in Africa. There are things I'm seeing that give me hope, that make me think other things could happen. And I want to focus, so I want to just like talk about 3 of these things now. And okay, so let me start with the first one here, which is the rise of OpenAI, which is really about the rise of a pretty thriving and surprisingly thriving open ecosystem in the AI landscape, right? And so like one of the things I want to say, some of you may know this already, so sorry if I'm kind of revisiting territory, but openness in AI is actually kind of a complicated thing, unlike with software where it's pretty straightforward. It just means you get the code, you see the code, you can modify the code. In AI, there's various degrees of openness in AI, right? You can get just the weights, you can get the training data. It can mean all kinds of different things when people talk about open AI. But the way I'm going to define AI here is what it's not. Okay, open AI is not closed AI, which is what most of us are using now when we get on ChatGPT or Claude, right? You don't know what's going on inside those models. You can't modify them. You don't know much about the training data. And importantly, you're typically running them off another server, like somebody else's computer server, and you don't really know what's going on there. And very importantly, they have the ability to change the rules, right? So like if you get on Reddit, it is full of small-time app developers who have built businesses on top of these models, and then like day to day, the rules switch, and all of a sudden they're shut off from the models and their businesses die. This reminds me of what happened to the media ecosystem with Meta, right? So that's what like a closed ecosystem looks like. But with open models, you can download the model, run it on your own machine, modify it to your needs, fine tune it with your own data. And this is especially important, I think, for smaller organizations, and by the way, smaller countries too, that don't have the capacity to build their own models, but also are scared of being dependent on American and Chinese companies and models. Okay, for example, I mentioned that I've worked in Rwanda, which is very concerned for a whole bunch of reasons about being overly reliant on US companies, and equally concerned about being reliant on Huawei and on Chinese companies. And so they've been pushing very hard to deploy open source in their country. The Europeans are increasingly aware of this risk, right? Like Greenland and tariffs was like one thing, but I mean, they could get cut off from the US stack, right? Which would have seemed imaginable, the US tech stack, which is why the French, for example, are pushing to have their own version of Zoom and things like that. So I don't know how many have heard of Mistral, which is a French AI company that's really pushing open source. Okay, so I guess the point I want to emphasize is that like what happens when models are open or when the ecosystem is open is that it basically allows more diversity and more multiplicity in the system. I think that probably instinctively makes sense, but there are a couple specific pathways by which that works. First, open models, they dramatically lower the barrier to entry. So a university lab, a small startup, a government agency can take an open model, deploy it on their own servers, modify it to their needs, deal with biases, control biases, impose or have certain guardrails around it. Open models also encourage experimentation and innovation, which automatically kind of leads to the multiplicity and the diversity that I'm talking about. in the ecosystem. And so that's one aspect of open models. And I just want to emphasize again, like how this open ecosystem has come about and how much it's flourishing, because I think it's actually, when we think about the mechanisms that may lead us down a better path, they can be very surprising, right? And I think, like, to me, the kind of like the rise of the open ecosystem has been very surprising. It's actually come out of China in a way. And I'm sure some of you might remember that DeepSeek moment from about a year ago. And a lot of people focused on the fact that it was very low cost and that it was done at very low cost with, chips that weren't as sophisticated. I think actually there was a little of trickery going on there. Like, I think they had access to more chips than they were supposed to have access to. But the part that people focused on less was the fact that this was actually deployed and was handed out as an open model. Right? Handed out is sort of the wrong term, but was put out into the world as an open model. And the really interesting thing about this was that this actually created a geopolitical situation where it created competitive pressure towards openness, right? And so, like, very soon after that, OpenAI, which, like, in some ways was like the epitome of a closed model, released its own open model in the world, because it realized that if it was going to be competing in a global ecosystem, it was going to have to be open. And so that's kind of that's sort of been the pressures that have pushed us towards openness, which I think are a very interesting way, like competition as a kind of lever for openness. We can talk about some of the, if you're interested in, we can talk about some of the risks associated with open models, because it's not a sort of like, unmitigated good. But moving on, I want to move on to the second trend that, as I said, is pushing us in a more positive direction. And that is the rise of smaller, what I call lightweight AI. So it's the emergence of lighter, cheaper, less capital intensive forms of AI. Some aspect of this sometimes referred to as edge AI. It's taking place at many forms and at many levels of the AI stack. Again, I keep seeing this in my work, especially in the global South. And I mean, I guess like one way to think about this is, most of us know that, not that long ago, computers took up rooms this size, right? And so, we've moved from an era of mainframe computing to personal computers to cell phones. And we might be in a mainframe moment of AI, right? Like, for all the attention that's given to the billion-dollar investments and to the huge data centers that are sort of like, occupying the heartland, there is a train of thought that these will be like the industrial smokestacks kind of our era, and that we might be in a very different place. And we're seeing this, for example, with the rise of smaller, more specialized models that are actually built on top of AI ecosystems. I suspect that might have come up here in the conference, actually, that some of you might be using more specialized models. But I see this a lot, like in the global South. I see them using, models that are specifically trained on agricultural data in East Africa or West Africa. And these are then put on top of open source models, but it's just a much lighter way of deploying AI that is not as capital intensive. And another important thing is it's not just that the models themselves are smaller, but it means that it greatly reduces the compute power required to run these models, right? Which is a huge part of the cost now. And again, I've seen this happening a lot. I mean, I was in Cape Town in November at a tech summit that was very focused on kind of frugal AI and AI in the global South. And one of the companies I met with there is a company called Crane AI Labs that's doing this work in Kampala, Uganda. And I was kind of skeptical, but the guy actually like sat me down and shows me his model on his like old Samsung phone running offline. Very impressive. Now, is that as good as, your most advanced ChatGPT or Anthropic model? No, but actually the part of the point here is that for most deployments in the world, we don't need that level of sophistication. Those are generalist models that can do all kinds of stuff, and you might need them for some very sophisticated math problems, but for or scientific problems, but to predict sort of like weather patterns or crop patterns in a particular field in Tanzania or whatever, some of these smaller, more lighter and more specialized models are actually very well suited and perfectly suited to that. So, okay, again, we can come back to the frugal and lightweight AI and their relative performance. I guess one thing I want to say, because I do get asked this question sometimes about like this vision and the relative performance of open models and frugal AI. I mean, the open models, by most accounts, are about 6 months behind the leading frontier models right now in terms of most benchmark performance, which is kind of wild, right? Because like you look at these funding rounds, you look at the billions and billions and billions they're raising, and then like the guy right behind them that's kind of like walking along, in sandals, like without a shirt on, is like 6 months behind them in performance. So, I mean, that's just something to think about. All right. The third and kind of final countervailing trend is something that this is sort of the field that I work in, which is it's a broadly, I would define it as public AI. It's the most ambitious. It's also like the most complex. It may be the hardest to achieve. And just to kind of like explain where I'm coming from, some of you might be familiar with this notion already, but if you think about the AI, what we call the AI stack, it's many things, right? Like AI is not a single technology. It's many layers. You have data, computing power kind of at the bottom. You have the model sitting on top of that. Then you have the specialized models, and then you have the apps and the platforms on top. And so, there's different intervention points that are possible at different layers of this stack. And I think one of the sort of key motivating insights behind the notion of public AI is that some parts of this stack are more foundational than others. And we should think of those elements as kind of like infrastructure. And it's really important for those to be open, to be democratic, to be widely accessible, because they have huge upstream or downstream, however you want to phrase it, they have huge effects on the rest of the stack. And so interventions there or changes that we can make there have a disproportionate kind of effect on the overall ecosystem and in terms of sort of like creating diversity and multiplicity. So again, we want to think of them as infrastructure. And then, once you think about them as infrastructure, it sort of changes the way you look at this because, sometimes they get compared to like digital roads or digital plumbing or digital bridges. And then you think about how we build roads and bridges and plumbing, or at least how we should build them in like a healthy society that invests in them. But it should be unthinkable to have three companies running every form of infrastructure in the country, unilaterally determining what the terms of access are, unilaterally determining how much it costs, who they can include, who they can kick off, and things like that. And so the core idea of public AI is through some combination of regulation and public investment to be building these foundational models in parallel to the private infrastructure, but so not necessarily replacing them, but in parallel, and to be building out that capacity to unleash, a lot of innovation higher up in the stack. I'm pretty sure you can all sort of see how this would lead to more multiplicity and diversity. You might also be skeptical that this will actually happen, and that's fair enough. What I would say is, again, in the US at the federal level, we are not seeing much of this. I mean, the NSF is doing some of this, but, let's just say right now at a federal level, we're not seeing a lot of investment in public AI capacity. We're seeing a lot more energy in this area in the States. Massachusetts, California, New York, some of the universities are building out this kind of capacity. And again, we're seeing a lot of this kind of energy actually outside the US, right? So India, for example, has a huge AI mission where they've now got 30,000 chips that they're providing at subsidized or free rates to academia, civil society, startups. Europe has done a lot of work in this area. Switzerland, Spain, England, I know some of the people building this stuff. Morocco has a supercomputer that provides access, especially to academia in parts of Africa. So we are seeing efforts to build this kind of public AI infrastructure in parallel and as an alternative to the private infrastructure in much of the world. So those are kind of my 3 points, and I haven't really been tracking my time, but I'm gonna end there. And I guess I just wanted to end by reiterating this idea that we are early enough now. I think we have a choice. I think there are things we can take. And some of these choices are at the level of regulation and policy, like we can fund public AI initiatives. Government procurement, by the way, is coming up as a really interesting strategy because the government buys so much tech. And so if the government procurement is oriented towards openness and plurality, that actually creates huge competitive pressures that pushes the overall field. But like some of this is also a little less, is a little less tangible. It's more kind of like psychological or vibes and goes back to the kind of negativity or the loss of hope that I think many of us feel. There's a kind of, I think there's a certain amount of resignation in the world about tech, and part of this is the tech industry itself is very good at presenting what we, at least in academia, call a teleology kind of tech. That I know that the Biden people I knew in the Biden administration would have this. They were there when the AI moment hit, and the guys would come in from the labs and they'd be like, "You have no idea what we have here under the hood. Back off. don't screw it up, don't ruin it, and let us do our thing. And this scares people, right? And people are like, but you messed us all up, you ruined the world, but at the same time, I'm scared because you know everything and you seem to be doing everything. And that's not true, right? That's not true. That's a very self-serving narrative. There are things we can do, there are levers we can pull, and ultimately what tech does in society is a product of choices that we make. And so I'm not calling for like a sort of like storming, the ramparts here or whatever, but I'm just saying a little more like hopefulness and positive energy than some of my friends at least have would probably take us a little further. So, all right, thank you for that.
Final questions or comments?
Yeah, I'm going to ask, we're going to have, let me just make a pre-announcement because our reception will follow immediately. I will say, this is not for the online audience, but basically for our in-person audience, at 6:30, they turn off the lights and lock the doors. So basically, so this is going to be my last question. I'm going to ordain this as the last question of this conference. And one of the things that was interesting is that when it was July of 2025 that we started talking about having this conference, and we were told about the state of interest in AI here at Rutgers. And they said, well, the scientists want to do more and more and more, and the humanities people want to stop it. So why do you think there's so much hostility in the humanities toward AI? I mean, I think that it's my own thought. Well, my own thought doesn't matter because I'd like to hear what you have to say about it.
Well, so there isn't in this room, right? I mean, in general, at the conference among your people. I was just wondering because I started off my talk with that, and as I was writing it, I wondered if I was like overplaying it or overdoing it. But I think there is a lot of hostility. I have humanities friends of mine at Princeton. I'm really not. This is going to sound like a caricature, but it's actually the truth. Like very intelligent people who ask me, tell me one good thing that's come out of tech in the last 20 years. It's like, you want to take a balance sheet, sure. Like you make the case that there's been a lot of harm. So I think that's true. I mean, I don't really know, Corey. You probably know the kind of like, some of it is funding. Like there's all kinds of different things. Some of it is just institutional and kind of like organizational, right? I think there is a certain amount of just like existential kind of dread and distrust. I know that, but I think some of it is like a sense of being embattled. I certainly know in my journalist and writing community, that's a huge part of it. People feel their jobs are going to be taken away by the machines. And there was just this crazy, what was it, yesterday or the day before, this crazy poll that came out where they, ran New York Times stories written by humans and AI and asked people to vote on it. And a majority said they preferred, the AI version. I mean, so yeah, that would breed bitterness at the world. I would say that then like just breeds general resentment. But maybe just to be like a little more thoughtful about it, maybe also we don't know some of the, like we don't see or read about some of the hopeful, better stuff that's going on. Like that was part of my point that I was trying to make. Like a lot of the coverage, partly maybe for the reasons we just said, is very negative. And I know, editors at the Times have told me this even. They say, oh, we know that our coverage has been very negative and we're trying to figure out how to cover this more constructively. So I'm not sure, like this would go to the sort of like, what are the levers to sort of push us down a more hopeful path? I think it begins with like believing that path exists. And instead of pushing for moratoriums on AI development or whatever, saying, let's do it in a thoughtful way. Let's invest in public AI. Let's like push AI, but in a different way.
Well, thank you. And first of all, a round of applause for Akash Kapur. This has been phenomenal. And the last word will be our chair of classics here at Rutgers, the State University of New Jersey, Serena Connolly.
Thank you so much, Corey, and thank you so much, Akash, for that amazing, inspiring, and positive note on which we are bringing this conference to a close. I'm so glad this is happening on a Friday. I think I'm going to need the weekend to like absorb everything. I feel like an undergraduate. I have learned so much. It's absolutely incredible. And it's amazing that our old field is doing so many new and exciting things. What I've noticed in particular with all of our speakers as they're talking about the research they're engaged in is how collaborative that is. It is quite extraordinary. If there's one big change from the way we have been doing things in the past, where we've been producing single author scholarship, I'm seeing a future in which there is a huge amount of collaboration, and I think that's amazingly positive. Conferences too are collaborative endeavors, and I'd like to give thanks to, so many people, to Rutgers University New Brunswick School of Arts and Sciences for their support, to Rutgers University Libraries, to our Provost at New Brunswick, Jason Geary, who joined us yesterday. Of course, to our speakers. Without our speakers, there is no conference. Our speakers, absolutely amazing from beginning to end. Thank you too to our audiences in person and online. I love the fact that we could make this a hybrid conference. To my co-organizers, Corey, this was your idea. All of this was your idea, and thank you so much for making this happen. To Francesca Giannetti of Rutgers University Libraries, to Christina Demitre, who joined us yesterday, and to Christina Chu, who also joined and presented yesterday. Christina Chu and Francesca doing double duty. Extraordinary. To our graduate students, Eileen, Jordan, Daniel, you moderated sessions, you worked the microphone as well. And to the other graduate students as well. It's been amazing how many graduate students have come up to us and said, how can I help? So thank you for doing that. And most of all, the lanyards that all of you in person are wearing, the programs that you've been looking at, the food you've eaten, the coffee you've drunk, so much coffee. The Zoom link on which our Zoom audience have been joining us for these 2 days. All of that has been made possible by one person, and that is Kate Armbruster, our program coordinator in classics. Kate, please stand so that we can acknowledge and thank you. All right, so we have a reception outside. So thank you and goodbye to those of you who are on Zoom. And let's move outside, continue the conversations and eat. Thank you.